This is my third video lesson for the covalent bond unit. In this lesson, we'll be learning how to draw Lewis dot diagrams of covalent compounds with double and triple bonds. So we're going to build on what we learned in the previous lesson. So let's go to page 10 in the class packet. Motivation. Draw the Lewis dot diagram of O2. Is it possible to only have single bonds? Why? So take a moment to try to do it yourself. Resume the video once you complete it. Learning target. At the end of the lesson, I'll be able to draw Lewis dot diagrams of covalent compounds with double and triple bonds. Announcement: there will be a homework number 3 Junipod based off this lesson. There will be a quiz Junipod based off PowerPoint 1, 2, and 3. I am going to use the same strategy from the previous lesson using method B. Method B is much better than method A when it comes to double and triple bonds. So step 1, we must first count the total valence electrons in O2. Each oxygen has 6 valence electrons, so since we have 2 oxygens, that will be a total of 12 valence electrons that are present in this molecule. In step 2, we must determine the central atom, but since it's only one element, we can designate one of these oxygen atoms as the central. Then we draw a bond to connect both oxygen atoms. Keep in mind that each line represents a bond, which is 2 electrons. So how many valence electrons left over? In the beginning, we had 12 valence electrons. In this step, we use 2. So 12 minus 2 is 10. We still have to put these 10 electrons somewhere in this molecule. In step 3, we're going to designate one of these oxygen atoms as central. I highlighted the central atom as red. Now we're going to fill in the electrons. So the non-central atom will get 6 valence electrons, and the leftover will go on the central. So since we added 6 in this step, we're now going to add the rest, which is 4 electrons, onto the central atom. We added all the valence electrons. If you count, we added all 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we cannot add any more valence electrons. So now we're going to count the electrons in each atom to ensure that each atom has fulfilled the octet rule. Keep in mind, the bond is 2 electrons that are shared between 2 atoms. Let's count the first one. So this one has 1, 2, 3, 4, and is sharing 2. So total is 6. For this oxygen, you have 1, 2, 3, 4, 5, 6, and is sharing 2, so it's 8. So notice that one of the oxygen has not fulfilled the octet rule, but we cannot add any more electrons to this oxygen. To solve this, the atom that has the full octet must share more electrons. In this case, it is the black oxygen that's going to share more electrons. So by sharing 2 electrons, it's going to form a bond. So now we have a double bond between these 2 oxygens. So our next step is to double check the electrons using the octet rule. So let's count. How many electrons does this red oxygen have? It has 1, 2, 3, 4, and is sharing 4 electrons. So the total is 8. This black oxygen has 1, 2, 3, 4, and is sharing 4, so it still has 8. How many pairs of valence electrons are being shared? Since it's a double bond, it is 2 pairs. Number of valence electrons being shared, a double bond is 4 electrons. So remember, each bond or line represents a pair of electrons or 2 electrons. Another way to check your answer is that according to the guideline, each oxygen typically forms 2 bonds. So in the case of O2, each oxygen has formed 2 bonds. Learning check number 1. What is the total number of electron pairs shared between the 2 atoms in an O2 molecule? Pause the video and resume once you have the answer. O2 has a double bond, and a double bond is 4 electrons or 2 electron pairs. So the answer is choice 2. This is just a reminder, these are the guidelines. Carbon typically forms 4 bonds, nitrogen 3, oxygen 2, hydrogen and halides 1. But in all cases, octet rule is the priority. Typically, the central atom is the one that forms the most bonds. To review again, there's 3 types of covalent bonds, single, double, and triple. This is how you represent them in a Lewis dot diagram. and these are the number of electrons in a single, double, and triple bond. So let's do another example, carbon dioxide or CO2. So our first step is to count the total valence electrons in CO2. Carbon has 4 and each oxygen atom has 6. So the total is 16. In step 2, we must determine which element will be in the center. Since carbon has the smallest subscript and it forms the most bonds, it will be in the center. Next, we draw a line connecting each oxygen atom to carbon. So keep in mind each line represents a bond, which is 2 electrons. Since we drew 2 lines, we use 4 electrons in this step. How many valence electrons left over? In the beginning, we had 16 electrons. We used 4 in this step, so we have 12 left. We have to put these 12 electrons somewhere in this molecule. In step 3, we're going to place 6 electrons on every non-central atom. So I am going to add 6 electrons to each oxygen atom. So by adding these 12, I added all the valence electrons. In the beginning, we started with 16 valence electrons, so this molecule should have 16. Let me double check by counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we cannot add any more valence electrons. Now we have to count the electrons in each atom to make sure that each atom has fulfilled the octet rule. So let's count for this oxygen. 1, 2, 3, 4, 5, 6, and is sharing 2. So the total is 8. This carbon is sharing 1, 2, 3, 4. And this oxygen has 1, 2, 3, 4, 5, 6, and is sharing 2. So that's 8. Notice that this carbon has not fulfilled the octet rule. Therefore, the other atoms, the oxygens, have to share more electrons with this carbon. Since carbon only has 4 electrons, the other oxygen atoms will share the electrons. So let's start with this oxygen atom. It's going to share 2 electrons with the carbon. So now we form a double bond between the carbon and the oxygen. So let's count again to check if this carbon now has 8. So this carbon is sharing 1, 2, 3, 4, 5, 6. So the carbon does not have 8 yet. So this oxygen atom has to share 2 electrons with the carbon. So we form another double bond. So let's double check again. So this carbon is now sharing 1, 2, 3, 4, 5, 6, 7, 8. So now it has 8 electrons. So let's double check the other oxygen atoms. So this oxygen has 1, 2, 3, 4, and is sharing 4. So that's 8. This oxygen has 1, 2, 3, 4, and is sharing 4. So that's 8. So now we have fulfilled the octet rule for each atom. Notice if we're following the guidelines, carbon should have 4 bonds and each oxygen atom should have 2. Learning check number 2. Which molecule contains a triple covalent bond? Pause the video and resume once you complete this. So the answer is choice 2. So hydrogen will have a single bond, oxygen will have a double bond, and chlorine will have a single bond. I'll go over why nitrogen has a triple bond. So first, we got to figure out the total valence electrons in N2. Each nitrogen is 5 valence electrons, and since we have 2 nitrogens, the total will be 10. In step 2, since N2 has only one element, we're going to designate one of the nitrogen as a central atom. So I'm going to draw a line connecting the nitrogens. So in this step, we use 2 electrons. How many valence electrons left over? In the beginning, we started with 10. 10 minus 2 is 8. So we still have to put these 8 electrons somewhere in this molecule. So I'm going to designate one of the nitrogen as the central atom, highlighted red. Now we have to fill in the electrons. We're going to place 6 electrons on the non-central atom and place the rest on the central. So at this point, we added all the valence electrons. In the beginning, we had 10. So let's double check. We added 10. So if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we cannot add any more electrons. So let's count the electrons in each atom. So this red nitrogen has 1, 2, and is sharing 2, so it has 4 electrons. This black nitrogen has 1, 2, 3, 4, 5, 6, and is sharing 2, so it has 8. The red nitrogen has not fulfilled the octet rule. It needs more electrons, but we cannot add any more electrons. So the black nitrogen will keep sharing electrons until the red nitrogen has 8. So first, let's share 2 electrons. Now we have a double bond. Let's count to see if the red nitrogen has 8 electrons now. It has 1, 2, and is sharing 1, 2, 3, 4, so total is 6. So it still does not have 8, so the black nitrogen has to keep sharing. So now there's a triple bond between the 2 nitrogens, so let's count again. So this red nitrogen has 1, 2, and is sharing 1, 2, 3, 4, 5, 6, so total is 8. So now each nitrogen has fulfilled the octet rule. You can also double check your work using the guidelines. Nitrogen typically forms 3 bonds. Now I want you to try this one on your own. Pause the video and resume once you complete it. So CO is quite a challenging example, so I'm going to show you how to do it. Carbon has 4 electrons, oxygen has 6, so the total is 10 valence electrons for CO. In step 2, we must determine which element will be the central atom. In this case, both carbon and oxygen have a subscript of 1, but carbon forms the most bonds, so carbon will be the central atom. Technically, it does not matter which atom you designate as a central atom because there's only 2 atoms in this molecule. So I'm going to draw a line connecting the carbon and the oxygen. So how many valence electrons left over? In the beginning, I had 10 electrons, so 10 minus 2 is 8. We still have to put these 8 electrons somewhere on this molecule. Now I'm going to designate the carbon as a central atom by highlighting it as red. It does not matter which atom you designate as a central atom. If you designate oxygen, you'll still get the same answer. So now I'm going to place 6 electrons on the non-central atom and place the rest onto the central. Since we just added 8 electrons, we added all the valence electrons. In the beginning, we have 10, so let's double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we cannot add any more electrons. Let's count to see if each atom has fulfilled the octet rule. The carbon has 1, 2, and is sharing 2, so that's 4. This oxygen has 1, 2, 3, 4, 5, 6, and is sharing 2, so that's 8. So since the carbon does not have a full octet, the oxygen is going to keep sharing until the carbon has 8. So let's share 2 electrons first. Now we have a double bond between the carbon and the oxygen. So let's double check if we fulfill the octet for carbon. Carbon has 1, 2, and is sharing 1, 2, 3, 4. So that means it has 6 electrons now. It still does not have 8, so the oxygen has to keep sharing. Now we have a triple bond between the carbon and the oxygen. So let's double check if each atom has fulfilled the octet rule. This carbon has 1, 2, and is sharing 1, 2, 3, 4, 5, 6. So now it has 8. This oxygen has 1, 2, and is sharing 6, so it also still has 8. So now each atom has fulfilled the octet rule, so now you're done. So keep in mind, in this scenario, it did not follow the guidelines. This carbon and oxygen each have 3 bonds each. If you recall from the guidelines, carbon typically has 4 bonds and oxygen typically has 2. Remember, octet rule is the priority. Now I want you to finish 4, 5, and 6 on your own. Pause the video and resume once you complete it. Okay, so here's the answers. Here is another tool to help you draw the Lewis dot diagrams for covalent compounds. Sometimes you don't know where to start. This equation, will help you figure out possible structure details in your molecule. So this is known as degree of unsaturation. C stands for carbon, N stands for nitrogen, X is the halogens, and H is the hydrogen. So the purpose of this tool is to help you predict possible structure details in your molecule. Notice that this equation is not on your reference table. So how do we use it? Depending on your value of your degree of unsaturation, you can tell how many double, triple, or rings your molecule have. If your degree of unsaturation is 0, that means you only have single bonds in your molecule. So let's do an example. Learning check number 3. What is the degree of unsaturation of C4H8? Pause the video and resume once you complete it. So using the equation, you'll get that the degree of unsaturation is 1. So let's plug in the numbers into the equation, and we get the degree of unsaturation is 1. So what does that mean? That means we either have one double bond or one ring in the molecule. So this is very important because it gives you an idea what to expect, so you are not just randomly drawing the Lewis dot diagram until the octet rule is fulfilled. This equation is supposed to make life easier, not harder. If this equation is not helping you, do not use this equation. The reagent does not test degree of unsaturation anyway, but based off this equation, here are the possible Lewis dot diagrams of C4H8. Notice that each one is C4H8 and it follows the possible combination. There should be only one double bond or one ring. So which one is the correct Lewis dot diagram? All of them is considered correct. But are they the same substance? The answer is no. They are considered isomers of each other. Basically, an isomer has the same formula but different structure. All three of these have C4H8 as the chemical formula, but they're all drawn differently. They have different structure. These two have double bonds, but in different places. This one has a ring. Do isomers have similar or different properties? They have different properties. Why? Because of theme number 1. Structure influences property. Since they have different structure, they must have different properties. So let's do another example. Here's C4H6. So let's figure out the degree of unsaturation using this equation. If you plug it in, you get 2. Based off the table, here are the possible combinations. You can either have 2 double bonds, or 2 rings, or 1 triple bond, or 1 double bond, 1 ring. So if you were to draw these Lewis dot diagrams, here are the possible isomers. So notice this one has 2 double bonds, this one has 2 rings, this one has 1 triple bond, this one has a ring and a double bond. So this equation is very useful in predicting what is possible based off the chemical formula. Whenever you're stuck, use this equation to give you an idea of what's possible in the Lewis dot diagram. Let's do one more example. Here we have C4H4. Let's plug it into this equation. We get the DOU is 3. So based off the table, here are the possibilities, and here are the possible Lewis dot diagrams. For the last practice, I want you to draw the Lewis dot diagram based off the chemical formula. Pause the video and resume once you complete it. Okay, so here's the answers. So this concludes the video lesson for today. Remember to do the Junipod homework and quiz.